Meow meow. Oh yeah, you know what's happening now? You come and screw with everything, and then you try and run away because you don't want to be. Oh, look at me! Evidence. This is Willa. Yeah. Don't look. You are. I know. You're very nice. So, this is when you hear scratching or things knocking over or whining or wrestling. It's usually this one. I'm pretty sure in the background. Yeah. She claims no, it isn't. There's 3 other ones, she says, but I don't believe her. What we're doing this time is we're going to write the parametric and symmetric equations of a line L through a point 2, 1, 1 that's perpendicular to a given plane. So first of all, what I need from this is I have a plane P. You should draw a picture. My brain now can see this. And what you should know immediately is, given the general equation, which is often what happens in the start of a problem, we give you a plane in the general form because it's simplified, and it still gives us, the damn cat is actually rolling and trying to chew on everything right now. It's like I knew it was going to happen. The normal vector to this plane we already have in the problem. It's the numbers in front of x, y, z. So in this case we have 1, -3, 1 is our normal vector already. So we have that, and that is pointing perpendicular to the plane, which coincidentally is cleverly what this sentence is now trying to say. It wants the equations. We'll do the parametric and the symmetric avatars in a second, but what it's asking for is we want the line which is through this point. I don't know where the point is, P, but we can now move N through. N is in the direction of the line we want because it's perpendicular to the plane, and we already have it. And we have the point P, which is going to be through the line L. So the line L that we want, that is through the point P and in the direction of N, is this line specifically. And now that I see that, it makes it a whole lot easier for me to construct that. What am I going to do? I'm going to use, I now have, what do I need to build a line anytime, whether it's the parametric avatar or the geometric or the symmetric avatar. Here's the geometric avatar of it. We're going to do 2 horrible algebraic ones. First I draw the picture to see what's going on. Now I know to build this one-dimensional line and get either of its algebraic avatars, I need a vector in the direction, normally we call it V, but here I called it N because it was the normal vector to this plane. Someone likes to make convoluted questions. So I now have the vector in the direction of that line, and I have a point on that line. Long story short, that was a really convoluted way of saying I have the pieces I need. Once I have that, I can build both of the symmetric and parametric equations. So we do the parametric one first, and then we solve for t to get the symmetric. The parametric x, y, z equals. What do I need to build this line? I need a point on the line, 2, 1, 1. And then I need plus a variable t. That's why it's parametric, there's a parameter. And then what goes next to the t's? The vector in the direction of my line, which happens to be this normal vector. So 1, -3, 1. Usually we don't write it like that, we write it like this. X equals 2 plus t, y equals 1 minus 3t, and z equals 1 plus t. These are the parametric equations of L, the first algebraic avatar. Now from these, what we do is solve for t in each of them and write them in a symmetric, because they all look the same, so then we write them in a symmetric form. But right now, remember, this is the point that we need on the line, and then this is what is the vector, which we called n, I guess this time, in the direction of that line. The same information is going to be in the symmetric form. In fact, what we're doing is, I just wrote all over them, but we're going to solve these equations for t and write them in symmetric form. So I'm going to move the 2 over and then divide by 1. So x minus 1 over 1 equals t. Sorry, x minus 2. I caught it in real time. So I move the 2 over, I divide by 1, I have the first equation for the symmetric form. Now I solve this one for t. I bring the 1 over equals y minus 1, I divide by -3 this time. And then I solve for t in this equation. This will also equal z minus 1 over 1. those are all equal to t. So at the beginning you might want to write equals t to remind yourself, but this is what we call the symmetric equations of line L. It still coincidentally has all the information we need. Basically, what do we need? The denominator, even if there's a zero. Oh, I should have done when there was a zero, like in the class I usually do. So when there's a zero coordinate in the vector, we finally get to divide by zero, and lightning won't get us. I don't even have to dodge or try. It's not actually dividing by zero. What the denominators are saying is you're not dividing by zero, or you're allowed at least in this scenario, so do it. What it's saying is the denominator is my normal vector, or the vector in the direction of my line. So the vector in the direction of my line is the denominator. The numerator, the numbers in the top, is the point on my line. So it's, the symmetric form does have the information we need also.